Download this code from codegive.com, link in the description below. Cloning a Citroen/Peugeot ECU and BSI, a deep dive, with caveats. This tutorial aims to provide a comprehensive understanding of cloning Citroen/Peugeot ECUs and BSIs, body system interface, including common problems, necessary tools, and a conceptual code example. It's crucial to understand this is a complex and risky process. Improper handling can render your car inoperable and may even damage the electronic components beyond repair. Seek professional assistance if you're unsure about any step. Disclaimer *: This information is for educational purposes only. I am not responsible for any damage or problems that may arise from attempting this procedure. Cloning ECUs and BSIs can be illegal in some jurisdictions if done without proper authorization. Always verify the legality in your specific region. Furthermore, this tutorial glosses over many safety precautions best handled by experienced professionals. Why clone an ECU or BSI? Cloning an ECU or BSI is often necessary when *ECU or BSI failure * the original unit is damaged beyond repair, and a replacement is needed. Performance tuning * replacing the ECU with a modified version while retaining the original as a backup. Component compatibility * replacing a BSI or ECU with a used one from a donor vehicle, ensuring compatibility with the car's immobilizer and other systems. The immobilizer challenge *. Modern Citroen and Peugeot vehicles rely heavily on their immobilizer system, which prevents the car from starting without the correct electronic keys. This system involves *ECU, engine control unit controls the engine's functions. Contains the engine management software and interacts with the immobilizer. *BSI, body system interface manages various body functions like lighting, central locking, wipers, and also acts as the central hub for the immobilizer system. It contains vehicle-specific security information, like the VIN and immobilizer code. Transponder keys * each key contains a microchip, transponder, that emits a unique code when the ignition is turned on. Immobilizer control module *, often integrated within the BSI, verifies the key code against stored values and allows the ECU to start the engine if authorized. Simply swapping in a used ECU or BSI from another vehicle won't work because the immobilizer code won't match, resulting in the car refusing to start. Cloning aims to transfer the immobilizer information from the original, donor, unit to the replacement. Essential tools and software *. ECU/BSI programmer * a specialized device that can read, write, and verify the data stored in the ECU and BSI's memory chips, EEPROM, flash. Examples include *KES V2/KTAG * popular for ECU tuning and cloning. *FG Tech Galeto V54 * another well-regarded programmer. CarProg Full * can handle ECUs, BSIs, airbags, and more. VVD iProg * powerful programmer for various chip types. Soldering equipment * soldering iron, desoldering wick, solder, flux, often required to access the memory chips on the PCB. Hot air station is sometimes necessary. Multimeter * for checking continuity and voltage. Isopropyl alcohol and cleaning brush * for cleaning PCBs. EEPROM/flash clip adapter * can be used to read data directly from a chip without soldering in some cases, less reliable. ECU pinout diagrams * essential for identifying the correct connection points. Find these online, in service manuals, or through specific software. Software * Asterisk programming software asterisk provided by the programmer manufacturer, example K-Suite for KES/KTAG. Asterisk hex editor asterisk for viewing and potentially modifying the data dumps from the ECU/BSI. Example HXD, WinHex. Asterisk IMO decoding software, optional may be needed for more complex situations or to extract specific security information. The cloning process, step by step. Important considerations before starting asterisk. Asterisk identify the ECU and BSI asterisk locate the ECU, usually in the engine bay, and the BSI, typically behind the glove box or under the dashboard. Note down the part numbers from both units. This is critical to ensure you're using compatible hardware. Asterisk verify compatibility asterisk the replacement ECU and BSI should be the same part number or a known compatible version. Using incompatible components can cause serious problems. Asterisk backup the original data asterisk always make a complete backup of the original ECU and BSI data before attempting any modifications or cloning. This is your lifeline if something goes wrong. Store the backup in multiple locations. General procedure, this is a simplified overview, and specific steps will vary depending on the equipment and software used. 1. Disassemble the ECU/BSI, if necessary. Asterisk carefully open the ECU and BSI housings. This may involve removing screws or clips. Be extremely cautious not to damage any components on the PCB. Asterisk locate the relevant memory chips. These are typically EEPROM, electrically erasable programmable read-only memory, or flash memory chips. Common EEPROM types include 93CXXX series, 24CXXX series, and 95XXX series. Flash memory chips are larger and hold the program code. Asterisk refer to the pinout diagrams to identify the correct pins for connecting the programmer. To connect the programmer asterisk. Asterisk soldering method asterisk carefully solder wires from the programmer to the correct pins on the memory chip. Use fine gauge wire and a low wattage soldering iron to avoid overheating and damaging the chip. Proper flux is essential. Asterisk clip adapter method asterisk if using a clip adapter, carefully attach it to the memory chip, ensuring all pins are making good contact. This method is less reliable and can sometimes lead to read/write errors. Asterisk connect the programmer to your computer. 3. Read the data from the original ECU/BSI asterisk. Asterisk launch the programmer software. Asterisk select the correct ECU/BSI type and memory chip. Asterisk initiate the read function. The software will read the data from the memory chip and save it as a file, usually a .bin or .eep file. Asterisk verify the read asterisk most programmers have a verify function that checks if the data was read correctly. Run this to ensure the data is not corrupted. 4. Read the data from the replacement ECU/BSI asterisk. Asterisk repeat steps 2 and 3 for the replacement ECU/BSI. 5. Clone the data asterisk. Asterisk option 1, full dump cloning asterisk this is the simplest method, where you simply write the entire data dump from the original ECU/BSI to the replacement ECU/BSI. This is suitable for many cases but may not always work. Asterisk option 2, partial cloning, data transfer this involves identifying the specific data sections that contain the immobilizer information, example VIN, immobilizer code, key data, and transferring only those sections to the replacement ECU/BSI. This requires more knowledge and can be risky. It's sometimes necessary when the replacement ECU/BSI has a different software version. Asterisk option 3, IMMO off asterisk completely disables the immobilizer function within the ECU. This is generally not recommended as it compromises vehicle security. It can also be illegal in some jurisdictions. 6. Write the cloned data to the replacement ECU/BSI asterisk. Asterisk select the correct ECU/BSI type and memory chip in the programmer software. Asterisk initiate the write function. The software will write the cloned data to the memory chip. Asterisk verify the write. Asterisk run the verify function to ensure the data was written correctly. 7. Reassemble the ECU/BSI asterisk. Asterisk carefully reassemble the ECU and BSI housings. 8. Install the replacement ECU/BSI in the vehicle asterisk. Asterisk connect the replacement ECU and BSI to the vehicle. 9. Test the vehicle asterisk. Asterisk attempt to start the engine. If the cloning was successful, the engine should start. Asterisk test all other functions of the BSI, lights, central locking, wipers, etc., to ensure they are working correctly. Conceptual code example, illustrative, not functional. This is a highly simplified example using Python to illustrate the concept of reading and writing EEPROM data. Real-world programmers use specialized hardware interfaces and protocols. This code will not work directly with an ECU or BSI. Explanation of the conceptual code asterisk. Asterisk read underscore EEPROM, device, address, length, asterisk. This function simulates reading data from an EEPROM chip. In a real application, this function would use a library or API provided by the programmer manufacturer to communicate with the hardware and read the data. The address specifies the starting memory location, and length specifies the number of bytes to read. Asterisk write underscore EEPROM, device, address, data, asterisk. This function simulates writing data to an EEPROM chip. Similar to read underscore EEPROM, this function would use the programmer's API to send the data to the chip. Asterisk the simulated underscore EEPROM.bin file. This simulates the EEPROM memory. In a real application, you would never write to a file like this, you would be communicating directly with the hardware. Asterisk important notes asterisk. Asterisk this code is for demonstration purposes only and lacks error handling, hardware interaction, and other essential features. Asterisk real-world EEPROM communication involves complex protocols, timing considerations, and error checking. Asterisk the programmer's software typically provides a higher-level interface, so you usually don't need to write code at this level. However, understanding the underlying concepts can be helpful. Common problems and troubleshooting asterisk. Asterisk incorrect wiring asterisk double check all wiring connections to the memory chip. A single misplaced wire can cause read/write errors or damage the chip. Asterisk poor solder joints asterisk ensure all solder joints are clean, shiny, and make good contact. Use flux to improve solder flow. Asterisk chip damage asterisk overheating or excessive voltage can damage the memory chip. Use a low wattage soldering iron and be careful not to exceed the chip's voltage rating. Asterisk software errors asterisk ensure you are using the correct software version and that the programmer is properly configured. Asterisk corrupted data asterisk if the data is corrupted during reading or writing, the cloning process will fail. Try reading and writing the data again, and verify the data after each step. Asterisk incompatible ECU/BSI asterisk the replacement ECU and BSI must be compatible with the vehicle. Asterisk immobilizer issues asterisk even with successful cloning, there may be other immobilizer related issues that prevent the car from starting. This can involve key programming or other diagnostic procedures. Asterisk EEPROM lockout asterisk some EEPROMs have a write protect feature that must be disabled before writing. Advanced techniques asterisk. Data analysis. Analyzing the data dumps from the original and replacement ECUs/BSIs can help you identify the specific data sections that need to be transferred. Hex editing. Using a hex editor to manually modify the data dumps. This is a very advanced technique that requires a deep understanding of the ECU/BSI's internal data structures. Immo decoding software. Using specialized software to extract the immobilizer code from the ECU/BSI data. This code can then be used to program the replacement ECU/BSI. Safety precautions. Disconnect the battery. Always disconnect the vehicle's battery before working on any electrical components. Wear static dissipative equipment. Use a wrist strap and work on a static dissipative mat to prevent electrostatic discharge, ESD, from damaging the electronic components. Use proper lighting. Ensure you have adequate lighting to see what you are doing. Take your time. Cloning ECUs and BSIs is a complex process. Don't rush. Consult a professional. If you are unsure about any step, consult a qualified automotive electronics technician. Conclusion. Cloning Citroen/Peugeot ECUs and BSIs is a challenging but potentially rewarding process. It requires specialized tools, technical knowledge, and a careful approach. Always prioritize safety and double-check your work. Remember, seeking professional assistance is always a valid and often the safest option. Good luck.